Hello everyone, let's solve some Leetcode today. So today we have Leetcode 219 that is contains duplicate 2 problem. In this problem we have been given a nums array and an integer k. Now if there are two distinct indices in this nums array such that the values at those indexes are basically same and the absolute difference between these particular two indices is less than or equal to k, then we will simply return true as our answer. Otherwise we can return false. So this is one of the examples from Leetcode test cases. Here we have 1, 2, 3 and 1 element in the array with the indices 0, 1, 2 and 3 respectively. We have to figure out if there are two different indexes on which the values are same and the absolute difference between those indices is 0. So let's take a few pointers I and j. Right now we have I and j at 0 and 1 position. What is the difference between I and j? Well, absolute difference right now is I minus is equals to 0 minus 1 is equals to 1. So this is the absolute difference. We are not going to consider the negative sign. Clearly it is less than 3. It means one of the condition is fulfilling, but the values at these positions are not equal. So we cannot return true right now. Now the j will shift to this particular place. Now the j is 2. Well, I is still 0 and the j became 2. So it means it is 0 minus 2 and the absolute difference will be 2, which is still less than 3. It means one of the condition is still satisfying, but the element at index 2 is not equals to any other element in this particular window from 0 to 1. So we can definitely say that the other condition is not true. So right now we cannot return true. Now the j will shift to this particular index, that is 3. So now the absolute difference between the I and j is 0 minus 3, which is equals to 3, which is still less than or equal to 3. This is the condition that we have to follow. It needs to be less than or equal to k. So yes, one condition is fulfilling, and we can also see that the element at this particular index is actually equal to this particular index's element. So the other condition is also now true. So we can simply return true. Otherwise we would need to return false. Here I have modified the example a little bit. Here I have replaced 1 with 2. Now let's see what will happen at this particular index. We know that from here till here we won't get any true. So we will just ignore it for now and we will focus on these two indices 3 and 0. So the absolute difference between these two indices is still 3, which is still less than or equal to the given k. So one of the condition is fulfilling. But what about the other condition? Having these two elements same? Well, they are not same. So at first glance we can see that the other condition is not true. That's what it feels like. But if we think about it, we will realize that okay, we again have this particular element which have an index of 1 and the absolute difference between 3 and 1 is what? It is 2, which is still less than equals to k. So this particular index also actually fulfills one condition, but it also fulfills the other condition of having the same elements. So just think about it. If I have a pointer here and I keep incrementing this particular pointer, what I'm doing is that I'm always comparing between this particular pointer and this particular pointer only. And this is like a window. This is like having a window, right? So I basically have a window of length 3. If I try to go ahead and suppose that there was some other number here, I will go to this particular place. Now we know that this is index 4. Index 4 minus index 0, what? 4 minus 0 is equals to 4, which is not less than equal to k. So if it is not less than or equal to k, we know that we have to shift the I now. So it means that we are dealing with a sliding window problem where the window size is simply k. So here we can make two observations. First of all, every element that is present in this particular window will have this particular condition true. Because when j is at index 3 and I is at index 0, all the elements from 0 to 3 are actually going to have the absolute difference of 3. The second we shift pointer from here to here and from 0 to first index, we know that all the indices from 1 to 4 have an absolute difference less than or equal to 3. So this particular condition will always be true for a given valid window. So it means that we can say all the indices that belongs to a particular window will follow this particular condition for sure. But we still have a problem. When we were at this particular element j and the I was at 0th element, we know that the 1 and 2 were not equal. What this means is that I need to figure out that is there some element from 0 to 2 index that is equal to this particular element, the current element. But I cannot figure out just with the help of 2 pointers. Otherwise, I will need to repeatedly traverse the entire window, which is not a good thing because it will make the time complexity as order of n into k. And because we are going to traverse the entire array once, and the k is because we are going to traverse the window k n times for each of these windows. That is not an optimal solution. So how do we solve this particular problem? We can use an extra space. We can have a hash map in which we will store all the elements that we have encountered till now. So what we will do is, first of all, we will have I. So I will store this element 1, and then I will store the value as how many times I have seen 1. So I will say, okay, I have seen it once only. J will start from this particular index. So I will store 2 here. How many times have I seen 2 till now? Well, 1 time. How many times have I seen 3 now? Well, 1 time. Now, how many times have I seen 2? I come to this particular index and I need to check again, first of all, that have I seen this particular index earlier? In my hash map, I see an entry of 2 which actually have an occurrence of 1. So right here, I figured out that, okay, this particular condition is satisfying, having the same element at the indices. This particular condition, we know that it is going to satisfy for this given window anyway. So both the conditions are satisfying, we can simply return true. Now in case if this was not 2, if it was something else, for example 5. If it was 5 and I was forced to move forward, then what I will do is I will move forward the j, and since the window is not valid because the j is at 4, the I is at 0, which is basically 4, which is actually not less than equal to 3, it is making the window invalid. What I will do is I will also shift I from 0 to 1 index, and when I'm shifting the I will make sure that this particular 1 will actually be updated in the hash map. So now we are actually getting out of the window, we are leaving 1 here, so I will minus 1 here, so it will simply become 0. So now I am saying that there is no 1 in the current window, and this way we will traverse the entire subarray, and as long as we find these two conditions fulfilled, we will simply return true right then and there. Otherwise, at the end of the day, we can always return false. Now let us go through the code itself. First of all, I am declaring the hash map in which I will store the elements and their occurrences, or the number of times I have seen that element in this particular window. Then I am initializing my I variable, and I am also putting the element that was on ith index in my hash map first. I am running a for loop from j is equals to 1 to the length of the nums, as we have already seen in our example, and I am checking here that if the current window is not valid, then first I will go to my hash map and update that particular element's occurrence by 1. So I am simply subtracting 1 here, and now I am incrementing I by 1, and I know that it will always be valid at this point because we know that as soon as the size of the window becomes 1 more than k, we will be running this particular loop. So we just have to reduce it by 1. So we will simply say I is equals to I plus 1. After this, we will check does the element on the current jth index in nums actually exist in the hash map. If it exists, then we will also check how many occurrences are there for this particular element in the current window. If it is not 0, it means we know that we have encountered an element which is equals to nums of j in this particular window. So we can simply return true, else this particular line will execute. What I am doing here is simple. I am trying to get the element nums of j from my hash map. In case it is not present, I will simply use 0 as answer or the value, and then I will increment it by 1, and then I will store this particular value in this nums of j key in the hash map. So this line basically takes care of adding and updating the element. In case this entire for loop runs and we do not return true, we are very sure that there are no two distinct indices I and j where the value at those indices is equal and the difference between those two indices is less than or equal to k. So we can simply return false here. So now let's try to run it and see what happens. So yes, all the test cases are passing and our solution is correct. Now let's look at the time and space complexity for the solution. The time complexity is order of n because we are traversing the entire array with the help of sliding window technique only once. So that's why it is a simple linear time complexity of order of n. And in case of space complexity, what we are saying is simple. Whatever is minimum n or k, that will be the space complexity for this particular solution. And this is because if you look at the constraints of the problem, you will realize that n and k does not have to be equal, or k does not have to be less than n. Ever. The k can be a very big number and the n can be a very small number. N is the length of the entire array and k is the length of the window. So we are always going to store whatever is available in the window. But in case k is much larger than n, then we can only store whatever is available in the array. So minimum of k and n will be the space complexity. So what this line is saying is simple. The size of our hash map will always be equal to the minimum between k and n. But I also want to highlight that in our current solution, the space complexity is order of n. And that is because we are not actually removing the element from our hash map when those elements go out of the window. But if we remove the elements, this will be the time complexity. So let's remove them. So here I added the logic for that. Now in case the value at this particular key ever becomes 0 when we are shifting particular window, then we will simply delete that key from our hash map. And that will make sure that our space complexity is minimum of n and k. Now, of course, you can also use set in place of hash map, and that is probably a simpler solution for this problem. But I'm using a hash map because you can store the number of occurrences of a particular element in a window, and that will help you determine how many pairs like that actually exist in the array. In case somebody asks you, okay, I don't want to know whether they exist, I want to know how many of these kind of pair exist, you will definitely need to use hash map. So yeah, like the video, subscribe to the channel. If you have some kind of question that you would like me to target, if you have some kind of topic that you would like me to talk about, then just let me know in the comments. And now we will meet in the next video. Till then, bye.